So this video is a tutorial on unit analysis stoichiometry. So this is the normal way that we solve stoichiometry problems. It's the same way that we solved mole to mass problems, mole to molecules, mass to molecules, etc. So we do this by canceling units. I highly recommend that you have this graphic organizer to help you. So this video will be strictly procedural, meaning I will just tell you how to solve the problem, and then I will also post a video explaining conceptually why we do each step. Okay, so just keep in mind that when we're converting between mass and moles, we use molar mass. And remember that the molar mass is the number of grams in 1 mole of that same substance. And if we were to convert between moles and molecules, we use Avogadro's number, which is 6.02 times 10 to the 23, and that is the total number of either molecules or atoms that we have in 1 mole. And then in a previous video, I talked about mole ratios, where we use the ratio of coefficients. The ratio of coefficients is a conversion between moles of one substance in a reaction and moles of another substance in a reaction. Okay, so in this graphic organizer, where you see all these in orange, that would be measuring moles of one substance. We could also measure that in molecules, okay, or the mass of that substance. Green would be another substance in the chemical reaction. So the coefficients, just keep in mind those will come from the balanced equation. Okay. So let's try for our first problem. So I have C3H8 plus 5O2 goes to 3CO2 plus 4H2O, which is 1 mole of propane reacting with 5 moles of oxygen to form 3 moles of carbon dioxide and 4 moles of water. Okay, our first question says, how many moles of oxygen would be needed to produce 3.3 moles of carbon dioxide? So let's just pull the information that we need out of the equation. So I see that it's asking how many moles of oxygen, and it gives us 3.3 moles of carbon dioxide. Okay, so we're going from moles of one substance, oxygen, to moles of another, carbon dioxide. Okay, so if you look at your graphic organizer, if you're going moles of one substance to moles of another, we can do that in one step using ratio of coefficients. Okay, so you start by writing the given information, which is 3.3 moles of carbon dioxide, which is CO2. Okay, so ratio of coefficients. I'm going to show the ratio of the coefficients for these two molecules. Okay, so moles of carbon dioxide is on the top, so I put moles of carbon dioxide on the bottom. Okay, I'm looking for moles of oxygen. Keep in mind, ratio of coefficients is the only time where you have two different molecules or atoms in the numerator and denominator. So notice I have oxygen up here, I have carbon dioxide up here. They are not the same thing. Okay, so the numbers that go next to moles come from the balanced equation. That's why we call it the ratio of coefficients. So the coefficient for oxygen, if you look up here, is 5. So I will write 5. And the coefficient for carbon dioxide is 3. So I write 3. So notice these units cancel out. Okay, and then you're going to multiply the numbers on the top and divide by the numbers on the bottom. So you have 3.3 times 5 divided by 3. 3.3 times 5 divided by 3. You'll get 5.5 moles of oxygen. Okay, and you can watch a later video where I explain conceptually what this problem is actually doing. Okay. Next question. Okay, we're going to use the same balanced equation for all these problems. Okay, so this question says, how many grams of oxygen, so I'm looking for the mass of oxygen, that would be needed to produce 0.5 moles of water? Okay, so we go back to our graphic organizer. We have moles of one thing, and we are asked to find the mass of another. So if you look, we would have to do this in 2 steps. So first I'm going to use ratio of coefficients to go moles to moles, and then I can use the molar mass to go from moles to mass. Okay, so start by writing the given information. 0.5 moles of water. Okay, and we said the first step is going to be a ratio of coefficients. So just like before, okay, ratio of coefficients is moles to moles. I need to match the units to the top, so I know that moles of water is going on the bottom. Okay, I'm asked about oxygen, so I'm going to put moles of oxygen on the top. Okay, so for every 4 moles of water, okay, so I'm looking at the coefficient for water, I need 5 moles of oxygen. So I'm going to write the coefficient 5 for oxygen. So again, these numbers, since it's the ratio of coefficients, we use the coefficients from the balanced equation. Okay, so multiply the numbers on the top, divide by the numbers on the bottom. Your answer is 0.625 moles oxygen. Okay, apologize, should have crossed these out. Lots of moles of oxygen. Okay, so if we go back to this, we went moles of one substance to moles of another using ratio of coefficients. Now we're going to go from moles to mass using the molar mass. Okay, so molar mass is the number of grams in 1 mole. So I've got moles of oxygen on top. I'm going to put moles of oxygen on the bottom. Okay, how many grams are in 1 mole of oxygen? You would look at your periodic table. The molar mass of oxygen is 16. There's 2 of them, O2, so the molar mass is 32. Okay, so 0.625 times 32 divided by 1, which you don't necessarily need to include, and you will get 20 grams of oxygen. Okay. Another example problem. Okay, the question says, what mass of propane, which I give you the formula is C3H8, is needed to react with 96 grams of oxygen? Okay, so I'm asked to find the mass of something, I'm giving the mass of something else. Okay, so in this case, given the mass of one substance, I'm asked to find the mass of a different substance. So notice, there's going to be 3 steps. To get from here to here, I must go to moles, moles to moles, moles to mass. Okay, so I'm going to use molar mass, then I'm going to use ratio of coefficients, and then I will use molar mass again. Okay, so I'm starting with 96 grams of oxygen. Okay, remember whatever unit we have on the top goes on the bottom of the next step. So grams of oxygen. Okay, we know from the last problem that the molar mass of oxygen is 32. Okay, another thing to keep in mind, when you're using molar mass, this is the grams in 1 mole. The only time you write anything other than 1 next to moles is when you're doing the ratio of coefficients. Okay, so by definition, this is the grams in 1 mole, grams per mole. Okay, so 96 times 1 divided by 32, and you will get 3 moles of oxygen. Okay, mass to moles. Next step, since I'm trying to get down here, I'm going to go moles to moles. Okay, so back to the balanced equation. I have moles of oxygen on top, so I'm going to put moles of oxygen on the bottom. Okay, I'm looking for propane, so I'm going to put moles of propane on the top. Okay, we're not at the point where we can convert it to mass yet. Okay, so the coefficient for oxygen is 5. The coefficient for C3H8, which is propane, is 1. So you multiply the numbers on the top, divide by the numbers on the bottom. So 3 divided by 5 is 0.6. And that's moles of C3H8. Now it's very, very important that you include your units. That allows me to see where I'm at and what I'm going to be using in the next step. Okay, we went mass to moles, moles to moles. We're on our last step. Now that we have moles of the substance that we are looking for, we can convert that into grams. Okay, so moles of C3H8 is on the top, so I'm going to put 1 mole of C3H8 on the bottom. Now this 1 is not due to the fact that we have a coefficient of 1 here. This 1 is because it's molar mass. Just like in this first step, it was the mass in 1 mole for molar mass. We're going to do the same thing here. Okay, in 1 mole of C3H8, it is 44 grams. I got that number from the periodic table, so if you add up 3 carbon and 8 hydrogen, you'll get 44. Okay, again, we've canceled our units. We're left with grams of C3H8, which is exactly what we're looking for. So 0.6 times 44 26.4 grams of C3H8. Okay, and we already have the correct number of significant figures. Okay, I'm going to stop it here and continue in part 2.